Today I'm going to be showing you how to do an implicit differentiation problem that was actually submitted as a comment on one of my videos by one of Jake's Math Lessons viewers. But I'm going to show you how to do this problem in 4 easy steps that you can pretty much apply to any implicit differentiation problem. If that sounds good, be sure to stick around to the end of the video, and if you got any questions, be sure to drop them in the comments. Maybe, like this comment that I'm making this video based on, you'll end up getting your question made a video about. So if you do have any questions, even if they're not related to the video, just drop them in the comments and we'll see what we can do for you. Anyway, let's go ahead and jump on into the implicit differentiation problem. In this case, we're going to be finding dy dx by implicit differentiation. And the problem that we're going to be starting with, or the problem we're given, is x to the fifth times y to the fifth equals y plus x. So generally these implicit differentiation problems, whenever you're trying to find dy dx, or really d anything over d anything, they're going to follow the same process, the same few step process. So the first thing we want to do when we're looking at an implicit differentiation problem like this is, first of all, look at this right here. Look at what it's asking us to find. It's asking us in this case to find dy over dx. Well, this one little thing right here actually gives us a lot of information about what we're trying to find and how to actually get there, how to find it. So right off the bat, just by looking at, like I said, d anything over d anything, whatever you have on the top here, in this case y, that right there tells you right off the bat, we want to treat y as a function. So y is a function, and the thing that it is a function of, there we go, is going to be whatever this letter down here is. So right here we know x is going to be our variable. X is the variable. So right away we know y is a function of x. So you could almost think of it like this, y of x. Well, really all this is to say is when we're taking the derivative with respect to our variable, so we're always going to take d whatever this bottom thing is, in this case d dx, of both sides of our equation. When we're doing this, whenever we see an x, we can treat that as our variable. We can take the derivative of things that only have x's in them, just like you know how to take the derivative of anything, right? But where it gets a little weird, where you have to kind of apply the chain rule, basically, where you have to apply this kind of special implicit differentiation step, is whenever you have something with y in it. So basically, as we look through this equation, both sides of our equation here, we kind of have 3 main terms. X to the fifth, y to the fifth is one term, y is one term, and x is one term. When I say term, I mean anything being kind of multiplied together is going to be one term. If we have a plus or a minus, that's a separate term. So y plus x is 2 separate terms, where x to the fifth times y to the fifth is all one term. This term here and this term here, since they both have y's in them, we're going to have to apply the chain rule when we take d dx of both sides of our equation. But this term here, since it only has an x, we're going to be able to take the derivative of that as you would expect to be able to take the derivative of that. So all that really means is whenever we go through each of these terms and take the derivative of them kind of on their own, whatever has a y in it, we're going to have to treat a little bit differently. So when we're taking the derivative, we'll start on the left side of our equation here with x to the fifth times y to the fifth. Well, that's a product. We have the product of these 2 separate things here. So we're going to have to use product rule, actually. So when we're taking the derivative using product rule, we want to kind of break this down into f and g. So in this case, we'll just say f is going to be this first part, x to the fifth, and g is going to be this second part, y to the fifth. Then we're going to have to find f prime and g prime in order to apply the product rule formula. And this product rule formula is one of the formulas covered on my free Calculus 1 study guide. I did drop a live chat with the link to that. You can also look down below in the description of the video, and you can get a link to that study guide as well. It is free, available for instant download, and this formula is on there. But to take the derivative, or to take f prime, what we need to do is just take the derivative of this f term, which, since this only has an x in it, and we're taking the derivative with respect to x, since we're taking d dx, this one little piece only has x's, we can just use the power rule. The derivative is going to behave the way we would expect it to. So we're going to bring this 5 down in front, bring the power down in front, keep our base x as x, and then lower the power by 1. 5 minus 1 is 4. Now for taking g prime here, we're going to have to do something a little bit different, because now, keep in mind, we're taking d dx, which means we're taking the derivative with respect to x, and this has a y in it, which y is a function of x. So as a result, we have to use chain rule. What we basically want to do is treat this as we're taking some function of x, which is all being raised up to the 5th power. So chain rule says we have a function within a function. We have to use the chain rule. Well, the chain rule is just going to be taking the derivative of the outside part, so moving the 5 down in front, keeping the inside the same, keeping our y as y, that's not going to change, lower the power by 1, so make it a 4, and then by the chain rule, we need to multiply this by the derivative of our inside function. Well, the derivative of y is a little bit weird because we don't really know what y is. That's why we're doing implicit differentiation in the first place. If we knew what the function y was, we could just take its derivative, not implicitly, just explicitly take the derivative basically. But since we don't know what y is, we can't know what y prime is, or what the derivative of y is. So instead what we can do is just say the derivative of y with respect to x is just dy dx, which, you know, this notation literally just means the derivative of y with respect to x. So this is going to be our g prime now. Let me get this out of here real quick. All right, so now to apply the product rule, what we need to do is basically multiply this f times g prime, multiply the g times f prime, and then add those two things together. So we will do 5y to the 4th dy dx times x to the 5th, which gives us 5 x to the 5th, y to the 4th, dy dx. And then we're going to add 5x to the 4th times y to the 5th. Okay, so that is the derivative of the left side of our equation. Now for the derivative of the right side of our equation, we have y plus x. Well, we can just take the derivative of each of these two terms separately, since it's just the sum. The derivative of the sum is the same as the sum of the derivatives, which also is on my free Calculus 1 study guide I mentioned, linked down in the description. But what we're going to do is, I just realized I'm kind of cutting that off there. There we go. We can take the derivative of these two terms separately. So we're going to have the derivative of y, which, like I just said, if we don't know what y is, we don't know what the derivative of y is. But we do know, since we're taking the derivative with respect to x of y, that's just going to be dy dx. Then the derivative of x, since that only has x's in it, it does not have a y in it, the derivative is going to behave the way we would expect, because we're taking the derivative with respect to the thing that we're taking the derivative of. So the derivative of x is just going to be 1. So now the next step in any of these implicit differentiation problems is going to be to basically add or subtract all of our dy dx terms over to one side of the equation, add or subtract all of our non-dy dx terms to the other side, and then we'll kind of go from there. So first of all, we can see we have a few terms here. We have one term there plus another term there, one term here plus one term here. So what we're going to want to do is think about which terms have dy dx and add or subtract them all to one side of the equation. Doesn't really matter which. I'm just going to go ahead and move them all to the left. So this dy dx term is already on the left. This non-dy dx term needs to move over to the right then. So we'll subtract 5x to the 4th, y to the 5th from both sides of our equation. Whatever you do to one side, you have to do to the other side also. And then we have a dy dx term over here, which we want to subtract from both sides of our equation, so that we cancel this one from the left side, we cancel this term from the right side, and then what we are left with is this 5x to the 5th, y to the 4th, dy dx, minus the dy dx from the right side, and then equals this 1 that was over here on the right before, minus 5x to the 4th times y to the 5th. So now that we've got all of our dy dx terms on one side, all of our non-dy dx terms on the other side, what we can do is factor out the dy dx terms from the left side of the equation, or factor out the dy dx itself. Because what this is going to do is it's going to leave each of these terms within the parentheses here, but without the dy dx part of it. And the reason why that's really nice is because now we have an equation that only has one single dy dx, which is the thing we're trying to solve for. So it's much easier to solve for something when you only have one of it. So when you can, kind of add or subtract everything containing that thing that you're trying to solve for to one side of the equation and then factor it out, it reduces it to a single thing, which makes it a lot easier. And that's a pretty good strategy with any sort of problem that you're trying to solve for something, not just implicit differentiation. If you're ever trying to solve for a specific variable, that's another really common kind of helpful strategy that can be used in cases like that too. So now once we've got our dy dx factored out, we can divide both sides by everything within the parentheses here. So doing that is going to, divide both sides by this. It's going to cancel on the left, and we're going to be left with dy dx equals 1 minus 5x to the 4th, y to the 5th, over 5x to the 5th, y to the 4th, minus 1.
Well, I hope you found this video helpful. If you did, please be sure to hit that like button down below. And remember, implicit differentiation is one of the topics covered in my complete Calculus 1 package. If you haven't checked that out, there is a link down in the description below where you can learn more about that, and in the pinned comment as well. And I think you'll get a lot of use out of that, so be sure to go check that out below, and I'll see you next time.